Great. Okay, we have microphone is working quite well, so thanks everyone for coming. Because we are a highly concentrated crowd, we can make it very interactive. So if there are any questions in the middle or something, just try to interrupt me and ask me. What this talk is basically about is just I want to give you a quick overview about Gelato, what we do, our mission, which is helping projects decentralizing their web3 backend, realizing the need for not only having smart contracts be run by a decentralized network like Ethereum, but also some other components that are quite necessary for your application to be used by users and you not becoming the central point of failure when you're actually the developers or the projects themselves building the applications. Yeah, so if you have questions, definitely just interrupt me and we can talk about it. Let me just see if the clicker works. Yeah, it's this one. Cool, so we will very briefly go through sort of like backend architecture of Web3 applications today. They sort of assume still this notion of not being on your own chain, like not on your own application-specific chain. I think there are certain things that get added if you go into that area as well. But it focuses more on, like, let's say, if you deploy on an Ethereum or Polygon, for example. And then basically the services that we offer yeah, how you can decentralize your backend using Gelato, what we do, what we don't do, etc. Cool. So this is sort of, I think, many people when they join the space and they, let's say, on the hackathon like here, they think about how their application will look like from an architecture point of view. They got their front end, they got a couple of smart contracts, and they think, okay, hey, the smart contracts will be my backend, and that's sort of it for most parts. I can write my business logic in there. I can get my data storage in there, but of course, we all know this isn't really everything that is needed, and sophisticated applications look quite different to that. And there are several problems with smart contracts, or not problems, but limitations from smart contracts that make it so that you need a bunch of other things actually to build really scalable, sophisticated, and user-friendly Web3 applications. And so the first one that we realized with Gelato very early on is that yeah, smart contracts are actually not that smart. They're quite dumb. They just store some business logic, they store some data, some state, but they don't really self-execute their business logic, or they don't have this notion of event-driven execution or recurring execution, cron jobs, these type of things. And so for a lot of use cases, you need that sort of outside, you require an outside impulse to your smart contracts and actually to move data from A to B and to change state and to actually execute the business logic that you define within them. And this is actually quite interesting because smart contracts, they're not smart. Then, of course, we all know blockchains are very isolated environments. You need that sort of deterministic nature of an EVM or any other sort of contained virtual machine. And that means that you can't have them talk to, or it's not natively supported to talk to the outside world because you would introduce a bunch of uncertainty to the underlying blockchain. And so you need, again, other middleware to actually enable you to communicate to, let's say, a Web2 server or something else. Then we all know the user experience is terrible because we still require users to interact directly with the blockchain rather than sort of making it so we have this abstraction layer and we interact on their behalf on the blockchain, which is sort of like letting users directly write in your database or something in the Web2 world using some queries or whatever, and or calling APIs themselves, even though through like a Chrome extension, but sounds also weird. And then, of course, data is really, really difficult to actually get, especially historical data for your applications. If you want to show what happened a year ago, yeah, making that interacting straight with the blockchain is very cumbersome and very, very inefficient. So how it turns out, there are probably some other things as well, but this is sort of like how it usually looks like if you build an application. These are like a bunch of things that you require in order to have a truly truly scalable, user-friendly Web3 applications in place. So first of all, you have like to index the data of the blockchain sort of in parallel to new blocks being created, to then be able to, let's say, go back in time 100 days and see from 100 days to now what was the return that someone got by investing in a certain pool, let's say, right? This sort of like helps you solve this issue about data indexing and making it available. For that, you of course need databases. Sometimes you can opt in for centralized ones. Then there are of course like IPFSs or RWEs, which hope to be a bit more decentralized. And then you have this notion of, okay, these smart contracts, they can't trigger themselves, right? You can't update their state programmatically based on certain events happening. And so for that, you need like job schedulers, you need like event-driven transaction services, and you combine this job scheduler aspect with like transaction relaying, which is just a matter of, okay, how can I write to the blockchain in order to update its state, right? And you combine these together, and then you make your smart contracts actually smart and reactive and event-driven. Then, of course, you need off-chain data, fetching to fetch data from off-chain. You need a private key vault or some notion of someone sending transactions and signing transactions in order to actually update the state on-chain, right? And then, of course, you want notifications and alerting because, let's say, you run an investment sort of pool or a vehicle and something goes wrong or there's a hack or something weird happens, there's a deep hack, right? You want to get alerted as a team. Your customers should get alerted if something happens, like a transaction, an order was executed on their behalf, right? All these sort of notions are things you have to work and build in parallel to the underlying system, the underlying blockchain. And this is just like an example. Arrakis is this decentralized market-making service in Web3, and this is sort of how like some of the functionalities they need to do in order to actually off-chain, which is not supported by like the smart contracts themselves, to actually build the applications in the right way. They have to do a bunch of computation off-chain. They're building these very sophisticated strategies where they get the price data, volatility, volume. They run AI models to then define when to rebalance basically liquidity and when to rebalance money in Uniswap v3. And of course, they need to execute these strategies automatically, right? They need to send the rebalance transactions, and they need to send alerts to the team, so the team knows when something is maybe not rebalancing correctly. They have to have emergency stops, right? If some sort of weird thing happens, they need to stop maybe and send a transaction to their smart contracts. And yeah, then of course on the UI, they need to display to users, hey, what is actually the current price? What are the current prices? What are the APRs that you as a customer have gotten over the past 30 days, let's say? When did you deposit? When did you withdraw? And this is just a lot of data, a lot of calculations that have to happen off-chain in order to actually make it work. So a bunch of things. And yeah, there are of course a bunch of problems if you want to do all of that yourself. Just from a like managerial point of view, like the first ones, but then at the end, like the sort of notion of centralization. So of course you need to manage, scale, and maintain a bunch of server resources, especially if you go multi-chain. You basically have to sort of like replicate that, and it grows linearly for every new chain you add that you want to support, especially if you go to more sort of exotic chains. RPCs are still a huge issue. You can't really rely on a single provider, right? You need to have two, three RPCs to have redundancy in order to actually connect or even run your own node to have like a stable connection to a certain network, and even then it's not really guaranteed. And then you need to, maybe if you use other providers, you need to pay a bunch of them in different tokens and deposit them here, and your money is fragmented. Of course, there is this notion of private key storage, which is always very sensitive. But then if you do that all yourself, then, well, you basically become the central point of failure within your system. I think Michael from Liquidity did a great talk 2 days ago about like why decentralization matters, right? Your application, the goal is your application shouldn't be just be able to switch off if someone comes in, right, or demands that you do something. But if you control all the data, if you control the system that actually sends transactions to updates the state, then basically the application will be made useless if you don't have a more decentralized system where yeah, it can withstand some sort of censorship attack. Yeah, And this is sort of like what we try to do at Gelato. We try to help you with that and build your smart contract Web3 applications in a more reliable, user-friendly, and scalable way without trying to sacrifice decentralization and censorship resistance. This is sort of like the high-level goal. And for that, we really have like 3 main services that try to solve that or solve parts of the aspects. We don't do everything. There are other really cool middleware providers in the space that do a bunch of other really useful and interesting things. What we are really focusing on is like the smart contract automation part, helping you to do this event-driven, recurring transaction, like writing to the blockchain system. So whenever an event gets fired, you want to react to it and send a transaction. You want to check certain conditions off-chain every minute or so. This is what our automation service helps you. Web3 functions, I think I had a talk on Friday about it. It's really about bringing that notion of like writing to the blockchain programmatically on your behalf, but like using off-chain computation and data. Like you used to just be able to define smart contracts, and these smart contracts where you are like on-chain sort of computation environments that would tell Gelato when to execute a transaction. But now with Web3 functions, you can write like a TypeScript file off-chain that you deploy to IPFS, let's say. You say to the Gelato nodes, please run that particular basically backend sort of Lambda function for me based on certain events happening or every minute. And then if the logic is met, please execute. That's, for example, what Arrakis is using. If they are running strategies off-chain, they're using these functions that are being called, let's say, every time someone swaps in Uniswap, they will trigger this logic off-chain, which then sees, okay, can I rebalance my liquidity to now, again, like create some spread in the market that I want to achieve, right? This is all based also on like transaction relaying, which is just this notion of like, hey, help me get transactions written to the blockchain. And next to that, of course, you still need a bunch of other things. You need data storage, like an IPFS or Arweave. You need like indexing, like the graph, for example, right? You can actually, on top of Web3 functions, also add for more data integrity stuff like pull-based oracles, where you can actually pull data from oracles in and then run some logic on this and see if you want to send a transaction on-chain to update the price, actually, and then you can do it, right? So it's really focused on this computation and then writing to the blockchain for you. And this is sort of like how it works. Gelato consists of a bunch of validator nodes, Gelato nodes. These are right now whitelisted parties that we onboard case by case. Some of them are, for example, like staking facilities that they're, I think, also the biggest Lido node operators, Beware Labs, and some others. And what they do is they run this sort of like base client where they have to stake gel in order to get whitelisted and have to undergo some sort of whitelisting criteria. And then they can choose that they want to run some of these services. They can run like an automation service, just a transaction relaying service, Web3 function service. They all have different sort of, it's like a microservices-based system, so you can sort of opt in what you want to do. But if you want to optimize and increase your, or maximize your revenue, you basically want to run all of them because it provides you with most work. And for all of this work that you run, you actually get paid as a node operator. So there are 2 sort of fees in the Gelato system. They depend also on the services. There's one is a computation-based fee and one is transaction-based fee. Every time, let's say, you need to run a Web3 function, which is like this Lambda function, right? Off-chain, on behalf of a project, you incur, of course, some CPU costs, some memory, some RPC costs, and so on. And for that, you basically charge the project. We built this whole like payment system, like an off-chain payment system, which is super efficient, where you deposit USDC on Polygon, and you can pay for computation, and you can pay for transaction on all chains, on Ethereum, on Binance Chain, Avalanche, Arbitrum, whatever, just with depositing USDC on Polygon. Or you can deposit USDC on Arbitrum, and you can pay for transaction on Optimism, right? So it's all handled and abstracted from you under the hood, with Gelato basically fronting the network token always. And that money basically gets deducted for all users in certain intervals. So we push basically Merkle routes that define the state of everyone's balance on Gelato every like half an hour or so to all the chains, and this updates their cost basically that they incur with us. And yeah, if you basically run this computation off chain, and then you might end up in sending a transaction on chain, and this is really what Gelato is about. then you actually sign a message, you send it to another party, which are executor node operators, and these executor node operators, they are just very sort of simple, dumb parties. They just like take transactions and they have to follow certain rules, like go via flashbots, go via this private gateway, or go there, and then they get the transaction mined on chain. The goal for us right now is to make it so that everyone in the world can run these executors to actually send the transactions on chains, and then the validator set is a bit harder to make completely permissionless because there's some non-deterministic nature to that and some data integrity that is important to uphold. So there, yeah, we are right now basically making this approach of whitelisting people, whitelisting individuals, companies and projects in the space that have reputation that will run this according to our spec. But yeah, as soon as the transaction gets on chain, you hit the protocol, it does some checks like, hey, does this node have sufficient stake and stuff, sends it to the target contract, which might be MakerDAO, let's say, and then gets it mined. To give you a bit of context for like our automation service, let's say, you have these, let's say, like 3 customers that you probably know, like Jörn. Like, how does Jörn use it? Jörn uses our automate system to just harvest the rewards and fees of these vaults that they run, right? So they pool DAI from everyone, they put it into Aave or another protocol, they harvest some yield farming rewards there and some fees, and then they sell them all in one batch every day or so, and then recompound it into the pool. And so your assets increase in value over time there. MakerDAO has a bunch of in-protocol related tasks they have to do. They have to change parameters based on votes and do a lot of like cleanup, sell fees that are incurred and burned to Maker and these sort of things, all these operations that have to happen under the hood. That's what they use Gelato for, to automate that. They actually build a very nice sort of protocol-specific automation system where they can just plug into Gelato and just easily create all of these on chain. It's actually quite cool. And then Optimism, what they do use it for is they have to constantly push, they have to have these sequences, right? They have to constantly push transactions on chain, on Ethereum, right? With all the data of the transactions that are being executed on their L2. And this means they're burning through a lot of ETH. I think, yeah, the L2 sort of sequencers, they are burning through a lot of ETH. I think they're like the biggest ETH consumers on Ethereum, actually. And so these nodes that do that have to be constantly topped up and have to be constantly monitored to have sufficient ETH to pay for transactions. And so what they have the centralized smart contract. This is where they collect all the fees that they collect and all the ETH from their system. And then they have Gelato basically monitor the balances of all these nodes that send transactions, and then they send them to the nodes and top them up periodically in order to make sure their system isn't down and transactions get executed on chain. So this is like a common use case there, topping up systems, monitoring this, and then they can actually send alerts when these transactions are sent and so on. Yeah, for transaction relaying, this is really more about like UX. So this is really how can you level up the UX on your application. You might have, it's very, like you might have heard about the concept of account abstraction, right? Transaction relaying is a big part of it. And especially the problem here is not really like how can I get my transaction included in the chain, right? You have like concepts like use operations in ERC-4337 that you can use. You can use traditional just transactions where you just send a transaction via the regular, like ERC-4337 is just a different mempool that you can use, so to say, to get transactions mined. You can also use the regular mempool, or you can use flashbots, right? But it's really about the payment. So how do you pay for these transactions, and how can you as a project sponsor a transaction? How can users use tokens, let's say, that are in their noses safe to send transactions and pay for transactions? And this is where like this whole relay system comes together. It has a multi-chain payment system which works across many chains. And as a couple of use cases, for example, the Safe team, I think it was actually 2 days ago or 3 days ago, integrated Gelato Relay on their UI. So you can now, I think they're starting with Gnosis Chain, you can now basically just rather than having some signer of your Gnosis Safe multisig have to send the transaction, you can just like click a button and then Gelato will send it on your behalf if all the signatures have been collected. So you don't, especially if you have safes on multiple chains, you don't always want to like bridge your funds over to all the chains to then have someone that can click the button and send the transaction. So yeah, you can basically just click a button and have Gelato do it, and they will roll it out on all the other chains, right? So at some point, no one has to pay for transactions anymore when sending transactions on the Safe app. And we're actually working on a system right now. They're sponsoring it, so the Safe team is sponsoring all these transactions. Gnosis chain is quite cheap, so I think it's not breaking their bank. But we were actually working with them on a way where we can use the funds in your Gnosis Safe to pay for the transaction. So you just have to collect the funds in your Safe, and then you pay Gelato in the transaction with that. Connext is basically doing the same. They had this cross-chain messaging protocol or bridge. If you send a transaction on the home chain, they will send a transaction for you on the destination chain to bridge your assets, let's say, and they actually use Gelato's relay system under the hood. So the only thing they have to do is they have to deal with the liquidity of having sufficient assets on chain A and chain B, and they have to deal with the security of the system to make sure that the data is correct. And the user is actually allowed to mint tokens here and burn them here. And for all the transaction part, I use our relay system. And then, of course, you have like gasless NFT drops. Renault did one with us last year in December, for example. And this is just very cool, especially if you combine it with like smart contract wallets and web3 auth to have really like a super seamless user experience. I demoed it in the workshop on Friday, where you can literally just sign up with like your Gmail and then mint some NFT and they pay for it, right? So it's really cool. Web3 functions is our like newest system, right? And there I'm super excited about, and we just like rolled it out very recently. But there, what we are seeing is that projects leverage it to basically what you can do is you can call off-chain APIs, right? And then run some computations and transactions based on that. And how projects are using it is before something like Web3 functions, if you wanted to, let's say, periodically sell, let's say you accrue fees in your protocol and you want to sell them, right, to your native token to USDC, let's say, right, you had to build like a smart contract that routes through SushiSwap, Uniswap, Curve, whatever, to always tap into like liquidity. And now this whole routing, you can just do off-chain with like 1inch, call the 1inch API, and then just like send the transaction on-chain. And you basically save a ton of smart contracts. And this is actually something we see more and more. The more like they are all outsourcing logic that is not core to their protocol to off-chain and just do everything they can do off-chain and then just send a transaction that includes a route and a payload on-chain and just do it. And I think this is actually where this space is going. I think protocols might actually look like just like Gnosis safes, and then you just do all the computation that you want to do off-chain and then send a transaction, and then if your application is nothing else than just enabling people to go from Aave to Compound and then swap on Uniswap and then go back. Like back in the past, you had to build these smart contract systems that do that all, right? And these were like then Yearn or whatever, but you can do all of this off-chain and just send a transaction on-chain and then do it in one transaction and then have the funds be in the user's safe, right? I think this is actually what we're seeing. And this will actually make a bunch of protocols not that interesting anymore. But yeah, other use cases other than like 1inch APIs are calling subgraphs, right? Iterating through millions of NFTs and then sending transactions to buy or sweep the floor and do something like that. So yeah, these are a bunch of use cases we see, but also like prediction markets, dynamic NFTs, etc. So yeah, this is sort of like the Web3 function service and some use cases there. Yeah, and what's the mission here for us over the long run is we tried with Gelato to get as close as possible to Ethereum's security and decentralization. You should not be able to stop. If you set up a task with Gelato that should, for your protocol, update certain state periodically, you shouldn't be able to stop it. Like no one should be able to stop this process. Right now I think we are not quite there yet. But we are looking into a lot of different ways of achieving this. One thing that actually goes live right now is the gel staking, slashing not quite yet, but also this year. where node operators have to stake, and so they have some more they have some crypto-economic incentives to actually do what they're supposed to do, not only like off-chain contracts. Then we're actually looking into having Ethereum nodes run Gelato clients as well through something like EigenLayer, let's say, where we would like open up the system to not only allow gel stakers to run nodes, but also ETH stakers, basically. And this would really enable us to get as close as possible to Ethereum's decentralization. So this is something we're discussing quite heavily. And then, of course, you have the whole notion of ZK proofs, especially if you deal with deterministic off-chain computation that we are very much looking into. Though most of the cool stuff that developers are doing right now with Gelato is with like non-deterministic stuff and like off-chain data that is very hard to like ZK-fy. So that's why I think this is still a bit out there in terms of actual like real applications. Yeah, I think we're also like right on time. So this is some of our ecosystem map, a bunch of projects that we work with. Maybe one of your projects is also on there. Yeah, and if you are building something and need something like what we do, definitely reach out to us, let us know. And yeah, I think that's already it. Thanks for coming here this morning, guys. And if you have questions, just shoot at me.